Okay, hello and welcome to another lesson on further mathematics. Today we'll be talking about a motion in an inclined plane. So, but before we go into details of what we have now, let's make a quick review on our previous lesson. Okay, welcome back. Now, when you talk about inclined planes, you're talking about a plane that is placed at a 90 degrees plane. So this is a 90 degrees plane. This 90 degrees. So inclined plane, there are rules we use in solving it. Especially we apply Newton's law of motion. We are still in Newton's law of motion in solving motion on an inclined plane. Now let's solve the question that is in front of us. An object whose weight is 10 kg, that's the weight of this object is 10 kg, is placed on a smooth plane inclined at 30 degrees to the horizontal. So this angle theta is 30 degrees to the horizontal. Find the mass of this is 10 kg. Find the acceleration of the object that is moved down the plane. The velocity attained after 3 seconds if I, it starts from rest, and I, it moves with an initial velocity of this. Now let's start. Now force on the body downward force is, so A, downward force. Okay, we said the downward force is equal to mg sine theta. This is the downward force, the force acting pushing it down, mg sine theta. Then force on the body up, that's the force that is dragging the body. Remember, the body is falling down, so up, the force on the body up will be 0. Yes, because there's no force. Then force down the plane, that is that mg sine theta that we've got. So we now have it as mg sine theta and equal to m times a. So where A is acceleration down the plane, so this is 10 times sine 30 to be equal to 10 times a. Remember, they give us the mass here to be 10. This is it, 10, and we're given that is the same mass 10. Acceleration due to gravity we are told to take as 10. Then sine 30 is 0.5. So this is 10 times 10 is 100 times 0.5 equal to 10 times a. So this is 50 equal to 10. Value of a is 50 over 10, which is equal to 5 meters per second square. Since it's acceleration, that's the value of a. Now let's now start solving what we're being told to solve. They said find when it starts from rest, and you know at rest initial velocity, which is u, is equal to 0. Now we apply Newton's law of equations of motion, where v equals to u plus at. So and our u is 0. So we are told to find what? The velocity attained. So velocity equals to 0 plus a, which is 5 times 3 seconds. So and we've gotten our a to be 5 down here. So it's now v equals 5 times 3, which is equal to 15 meters per second. So this is it. If it starts from that point, that's the I point. Then I, you are looking for the velocity if the body moves with initial velocity of 5. Now at this point u is equal to 5. So we apply the same formula that says v equal to u plus 80. So at this point we have 5 plus, this is 5 times 3. So we now have 5 plus 15, which is equal to 20 meters per second. Now this is it for the inclined plane. Now I would like us to talk about connected bodies, which is still part of the same Newton's law if the bodies are connected. Now we shall examine motion of two or more bodies connected by a light inextensible string connected to a light smooth pulley. The basic assumption we make is that the tensile force on the string is always the same throughout every section of the string. We can easily write down the equation of motion of the connected particles once they are set in motion. Now let's try this question. Let's try this question. Now this is the nature of the connected body and the string. Nature of the connected body. Now the question says particles whose masses are 15 kilogram and 12 kilogram. So 15, 12 respectively are attached to ends of a light inextensible string. The string passes over a light frictionless pulley and the masses hang freely. The system is released from rest when the 15 kilogram mass is 32 meters above the floor. Find the tension in the string when acceleration due to gravity is 10 meters per second. Now the first thing we have to do is to get the acceleration of the 15 kilogram mass. So we say let the acceleration of the 15 kilogram mass be equals 15 gram minus the tension. So that's for 15 kilogram mass. Then so we now have it as 15 grams minus the tension is equal to 15A. So the net force, that is T minus 12 gram. Okay, 12, the question states 12 kilogram, so it's kilogram. Say T minus 12 kilogram. So apply Newton's second law of motion. Applying Newton's second law of motion. Apply Newton's second law of motion. We now have, as in T minus 12 kg. So it now becomes 3g is equal to 27a. Now with this 3g being equal to 27a, we now have the value of our value of our a becomes 3g over 27. So this is 1, this is 9, which is equal to g all over 9. So, and which is equal, and our g was given us to us as 10, so it's 10 over 9 meters per second square. So with that, we can now get our value of t minus 12 to be equal to 12a. So t is equal to 12a plus 12g, which is equal to 12 times 10 over 9 plus 12 times 10. So 10 times this is 120 over 9 plus 120. 120 over 9 over 120. 3 goes into 120, 40. 3 goes here. It's 3 times. And 3 goes, okay, no. 3 goes into 120 3 times. So the answer becomes 400 over 3. So this is the tension. The tension in the screen is equal to 400 over 3. I would like to say a very big thank you for being part of today's lesson. but I would just like you to take the test that will be appearing very soon in your screen. Do well to always make use of this lesson note as a reference material. See you in our next lesson.